Hello students, today we are going to discuss optical isomerism. Well, if you know, isomers are the compounds having same molecular formula but different structure. They show different behavior, different characteristics due to their difference in structure. So these type of compounds are called isomers, means having same molecular formula and different structures. But isomers are different types, maybe chain isomer, functional isomer, position isomer, metamer, so many types of isomers we know. But optical isomers, it is specific type of isomer. It has special characteristic that it will be changed when a monochromatic plain polarized light will pass through the solution. When a plain polarized light will pass through the particular optical, if it is optical active isomer, if it passes through the optical active isomers, then the optical active isomer rotates the light either clockwise or anti-clockwise direction. This is the only effect of light, that in presence of light these isomers rotate the light either clockwise or anti-clockwise direction. These are called optical active isomers. That means if light will pass, if you see, this is the light source. This is the light source. This is your light. Then light will pass through the. Then it will be converted to monochromatic light. Then it will be converted to monochromatic light. That is monochromatic light. Monochromatic light will be converted. Then this monochromatic light will pass through the nickel prism. When pass through nickel prism, then what happens? Then it will be what? It will be one direction. It will be in one direction. Light will be in one direction. It will be one direction. This is called plane polarized light. It is called plane polarized light. It is monochromatic but in one plane. Plane polarized light means it is monochromatic light having one single plane. Then when this light will pass through the solution, then if it is optical active, then it rotates the light either in clockwise or it rotates in anti-clockwise. Either clockwise or anti-clockwise. If clockwise rotates, this is called dextrorotatory. Dextrorotatory. This is called dextrorotatory isomers. If anti-clockwise, this is called levorotatory isomer. So two types of optical active isomers, that is dextrorotatory, another is anti-clockwise. This rotation is possible if it is optical active. If it is not optical active, there is no rotation of light. There is no change in the rotation of light. Here light is rotating either clockwise or anti-clockwise. Clockwise rotation is dextrorotatory, its symbol is D, short form is D, levorotatory symbol is L, and dextro also called as plus isomer, and levo is also called as minus isomer. These are the symbol of, that is notation, plus and minus, clockwise and anti-clockwise. There are two types of optical active isomers, and These two isomers, dextrorotatory and levorotatory, these two isomers called as, this is called optically active. Optically active means what? Optically active means either clockwise or anti-clockwise. You can write not plus, it is or. It is rotate, it is called optically active isomers. There are two types of optically active, either clockwise or anti-clockwise. So called optically active isomer and mirror image to each other. Mirror image to each other. Called optically active isomer and mirror image to each other. That's why it is called enantiomer. Enantiomers. What are enantiomers? Means optically active means either rotating clockwise or anti-clockwise, and these two, if one is clockwise, then another you bring another same formula, another form, that is anti-clockwise. Two isomers, same formula, but one is rotating clockwise, another rotating anti-clockwise. If clockwise and anti-clockwise rotation of same compound, if you bring two isomers, you bring, they are optically active because they are affected by plane polarized light. But if you see the structure, one and other is just like mirror image to each other. Means your left palm will be looks like right palm. If you show your left palm to the mirror, you will see it looks like a right palm. That's why your left palm and right palm both are mirror image to each other. That's why clockwise and anti-clockwise rotation of these two isomers. It is one isomer, it is another isomer. Both are optically active because it is rotating clockwise, it is rotating anti-clockwise. That's why optically active. But what if you see their structure, if you should see their arrangement, it is just mirror image to each other. That's why optically active and mirror image. These two form is very important. Optically active and mirror image. This is called enantiomers. This type of isomer are called enantiomer. Left palm, right palm, just like enantiomers. Because optically, that because mirror image to each other. So these are very important regarding optical active nature. Then, what are the condition for optical activity? Condition for optical active isomer. First condition is very important. Should have chiral center. Chiral center means it is called chiral molecule. Chiral center means chiral molecule. It is chiral molecule. It is also called asymmetric. Asymmetric means no symmetry is there. We will discuss that later. So should have chiral center. What do you mean by chiral center? Chiral center means suppose this is a carbon atom. If it is attached to like this, suppose A, this is B, this is C, this is D. All are different. It is called chiral center. This molecule is having carbon is a chiral center of this molecule and connected to 4 different groups. If the all bonded atoms or groups are different, that is called what? Chiral center, and the molecule is called chiral molecule. It is called asymmetric, means no symmetry is there. All A, B, C, D, all are different. So this is the first important condition. Second condition is these isomers should not be what? Support impossible each other. That means non-identical. That means non-identical. Non-identical. There is no similarity. Isomers should not be superimposed to each other. That means non-superimposed. Should not be superimposed means should not be superimposed. Superimposed means identical. Just you take just one football, plain football. If you divide it, it is to equal halves, identicals. Identicals, that is called superimposed to each other. They should not be superimposed to each other. That means non-identical nature. So should have chiral center. Chiral center means having different atoms and groups are attached to the particular carbon atom, and these isomers which are produced, these isomers should not be superimposed to each other. That means these two isomers should not be identical. For example, you look at your palm. If you see your palm, left palm and right palm are not identical. Left palm and right palm are not identical. They are different in that looking. You can easily identify this is the left palm, this is your right palm. Easily you can identify because they are different in structure. Structure are different. It may have 5 fingers. It may have 5 fingers, but the structure is different. That's why it is called non-superimposable. For examples, you cannot use your left hand gloves in right hand. Cricket gloves. Cricket gloves, left hand gloves cannot be used in right hand gloves. That's why these two are non-identical. That means non-superimposable. In this sense, you can understand in that way that isomers should not be superimposable to each other and should have chiral center. That means chiral molecules, asymmetric nature. Then third important point is should not have symmetry elements. Symmetry, they should not be symmetrical. So what are the symmetry elements? Plane, axis and center. Should not have plane of symmetry, should not have axis of symmetry, should not have center of symmetry. Like this. Suppose plane of symmetry, I will just want to have examples. Suppose this is one structure A, this is B, suppose this is C. Here this is A, this is B, this is C. If you see this structure, it is identical. You see, this is the plane, this is the plane. If you divide this into equal halves, upper halves equal to lower halves. So this is plane of symmetry. This is called plane. Center of symmetry, if you take like this, suppose this is one example, suppose this, so it is inactive, optically inactive. Optically inactive. Suppose this one, if you see, here the structure is like this, suppose this is R, here also this is R, suppose this is H, this is H, let it be. Here suppose this is R1H, here R1H. You can say this is a center of symmetry. Suppose this is the middle point of this structure. If you join, you see, same R1 is coming at this point. Same R is coming at this. That means this is the center of symmetry. Through this center, what? We can divide the molecule equal halves. Same R is repeated here, same R is repeated here. That means it has center of symmetry. So like this, molecules should not have any symmetry elements. Plane of symmetry, axis symmetry, center of symmetry should not be there. Then it will be optically active. If any symmetry is there, then it is optical. For examples, suppose CH3, CH2, CH3. It is optically inactive because it has no chiral center. It is same, methyl, same. Here H is same, so it is optically inactive. Optically inactive. because some identical molecules atoms are there. If the atoms are identical, then it may have planar symmetry or central symmetry or axial symmetry. So symmetry should not be there for optical active isomers. Symmetry should not be there. This is a very three important condition for optical activity. Chiral center and should not have the ions that compounds should not be or isomers should not be superimposed to each other. That means should be non-superimposable. Then and that should not have any symmetry. So this is regarding that condition of optical active isomer. But important thing we will discuss that suppose A, if I write A, this A, it has plane of symmetry. If you divide this, you see equal halves. So it will be plane of symmetry. Suppose P, if I write P has no plane of symmetry. So no symmetry here symmetry is that. Symmetry is no symmetry. That means it is optically inactive. Short form OIA. It is OA, optically active. Sorry, I have written wrongly. Reverse written. It is optically active. It will be optically inactive. Because symmetry here. If symmetry is there, then optically inactive. If no symmetry, optically active. M, if you write M, this structure. This structure, if you see, like this, equal. So it is optically inactive. OI is short form, optically inactive. OA means optically active. So in this way, we can identify which isomer is optically active, which isomer optically active. But in some cases, it is, for example, this structure. This structure is optically inactive because you see here all are equal. This side is equal. So it is optically inactive. But same structure you write here. If it will be X, if it will be Y, then it will be optically active. It will be OA, optically active, because this is the chiral center. Because you see here H is there, this group is not equal, Y is another group. That's why it is optically active. It should have different bonded atoms and groups. So it is optically inactive because identical is there, some symmetry is there. Here is asymmetric. The structure is asymmetric structure. Asymmetric structure means optically active. Symmetric structure means optically inactive. You have to think like this. But in some cases, some isomers that I will give example. Let us take some examples. You complete this one. I will written this point. You complete. Let me erase this one. Let us take some examples. This is a chiral molecule. Chiral means having different groups are attached to the particular center. So it is a chiral molecule. Chiral molecule means optical active. Optical active means it has mirror image. It has also mirror image. So this is your mirror. And what are the mirror image of this one? You can write it. This is your X and this is your Y. This is your C and this is your B. So these two forms, suppose if it is let it be plus isomer, it will be minus. If it is optical active, one will be plus and the mirror image will be minus. Always remember, if one will be plus, if you identify let it be plus. Plus means what? Clockwise rotation. Plus means clockwise. Its other isomer will be anti-clockwise. So this is called enantiomer. This is called enantiomers. What are enantiomers? Optically active. It is also plus, it is also minus. Plus or minus, both are optically active. But these two are mirror image. Left palm, right palm. Just like it is enantiomers. Because non-identical, all are not identical and mirror image to each other. That's why it is called enantiomers. Optically active and mirror image. These are called enantiomers. This trisomer is called enantiomers. Then, if I take different examples, suppose this one, H, OH, COOH, H, OH, COOH. This is called tartaric acid. This is example of tartaric acid. Tartaric acid. This tartaric acid, if you see, it has two chiral center. This is one chiral center. This is also one chiral center. Two chiral center is there. But this structure is optically inactive. This structure is optically inactive because here what happens, you see the mirror image is produced. Upper half is equal to upper half, just mirror image. First half is just opposite of the second half. So within the same molecule, you see the difference. Within the same molecule, here the different molecules, plus minus different. But here is same molecule, upper half is showing plus, let it be plus, and bottom is minus, mirror image. If this through this it is plus, those other side is minus. If plus minus both are there, they will oppose each other. Plus half will opposes to minus half, because these two are, you can say, mirror image. If mirror image, that means plane. You cannot say plane, mirror, it is plane symmetry, plane of symmetry. Upper half is equal to bottom, lower half. That's why it is optically inactive. Optically inactive. Short form is O, optically inactive. OIA. I have already told you. OIA means optically inactive. OA means optically active. So it is optically inactive because upper half and lower half just mirror image to each other. Sorry, plane symmetry. Upper half and lower half is identical. That's why what happens? Both opposing. If it is moving, let it be. If it is moving in the direction of clockwise, and it will be rotating anti-clockwise. Clockwise, anti-clockwise, these two rotations will cancel each other. That's why molecule will be optically inactive. This is called mesomers. It is called mesomers. Mesomers. Very important. This is enantiomer. What is enantiomers? Optical active and mirror image. But here what happens? This particular same type of isomer, but what happens? Here, this one half is opposing other half, and one half, other half just plane of symmetry. Symmetry is there. This is mesomers is called internal compensation. Due to internal compensation. Internal compensation means within the molecule, one half opposing the other half. One half opposing other half. That's why it is optically inactive. This is called mesomers. But if you write this other type of isomer, let it be like this: COOH and H. Sorry, it is OH and this is H. Suppose this is OH and this is H and this is COOH. This case, it is optically, what happens? Optically active. It is optically active. It is optical active because no symmetry is there. So as it is optical active, if you write this one, another form if you write Suppose OH, H, H, OH. It is also optically active, but these two isomers is mirror image. So this is called, if it is plus, let it be this plus, it will be minus because mirror image. This is called enantiomer. This is called enantiomers. Optical active and mirror image. Okay? But if you draw this form, I will draw this another one. Let it be like this. Suppose this is structure 1A, this is B, this is C, suppose this is D. If you see A and D, it is optically inactive. It is also optically inactive because plane symmetry is there, plane symmetry is there, plane symmetry. So it is optically inactive. A is optically inactive, so you can write OIA, optically inactive. A is optically inactive, D is optically inactive, but B is optically active, C is optically active. So B, C are called enantiomers because mirror image and both are optically active. But A and D, these two, what is the relation? AD just mirror image, you see, mirror image, but it is optically inactive, so mirror image, both are mirror image, this one, but not optically active. Mirror image, both are mirror image, but not optically active. This is called what? Mesomers. What are the mesomers? So A and D are mesomers, B, C are enantiomers. But you take anyone, suppose A with B. You take A with B. A with B. What is the relation? A is optically inactive. And B is optically what? Active. But AB, what happens? AB is not mirror image. These two are not mirror image. If not mirror image, these are called diastereoisomers. These are called diastereoisomers. So, isomers, that means having same formula but not mirror image to each other, are called diastereoisomers. But optically active and mirror image, that is called your mesomers. And diastereoisomers may be optically active or may be optically inactive, but they should not be mirror image to each other. But mesomers, what happens? Always optically inactive. Mesomers means optically inactive, but mirror image. Optically inactive. It is optically inactive, and mirror image. That is called mesomers. This one. If not mirror image, this is called diastereoisomers. So these are the A with B, A with C, C with D. Like this, we can say these are diastereoisomer pairs. So this is regarding the types of optical active isomers, enantiomers, mesomers and diastereoisomers. These are very important types of isomers, that is optical isomers. Another thing it has been observed that they have no chiral center. Without chiral center, how molecule will be optically active? For example, suppose this case. You see, this molecule, here what happens? Having COH carboxyl group, but this molecule is planar. Benzene means planar molecule. But these two groups, COH and COH, if they will come closer, they will repel each other. This group, this identical group, if they are coming together, then they will repel each other. So how they will remain? If they are remaining in this way, then the group will repel each other. They are repelling. But if I place the group like this, you see, the group in this way, you see, in this way they are repelling. If you have placed my palm is like this, so there is no repulsion. If it is coming in this way, then repelling. If I am placing like this, so if one group will be like this, another will be just vertical, then they will be what? Optically active. So if you see, you can say it is mirror image. If it looks like it has a plane symmetry, if it looks like it is plane symmetry, it is plane symmetry. But it is not like planar symmetry, because one group in plane, another will be just vertical, so that the group will be just remain one will be horizontal, other will be vertical. It will be like this, not like this, not it will like this, it will be like this. One will plane, another plane. So it will be optically active. It is formula looks like what? Optically inactive. But if they will remain in such way that it will be optically active. This plane and this plane will be different. If it is horizontal, it will be vertical. So it will not have any symmetry. That's why it is optically active. So another type of molecule you can see. If this example you take, it has plane of symmetry, that is center of symmetry. So it is optically inactive. This type of alkene is optical. This is called your trans. Optically, what happens? Optically inactive. But if I take this one, this case, suppose this is CH3, this is H, this is also CH3, this is your H, but it is optically active. It looks like what? Looks like symmetry is there. Looks like symmetry. If you divide this, it is symmetry. But no, here hybridization is sp2, here hybridization is sp, here hybridization is sp2. That's why, just already I told you earlier, this group and this group, one will be horizontal, other will be vertical. It will be looks like this. That means like this. It will be remain like this, not like this. So this is called allene. This type of group is called allene. Generally, allene conjugative double bond, if it is even number. Even number means always optically active. If you take odd number, then what happens? All will be, suppose this is sp2, it will be sp, it will be sp, it will be sp2. Then what happens? These two all will be in one plane. All will be in one plane. It cannot be one will be horizontal, other will be vertical. But this case, if you take odd number, odd case, Odd case means optically inactive, OIA. Even case, this is even. Two double bonds, even. Even means optically active. This is allene. This is one type of allene. This is one type of allene. Allene means having double bond, conjugative double bonds are there. So in this way we can know, although molecule already know if molecule has chiral center, it is optically active. That is called chiral molecule. These are disymmetric molecule. These are asymmetric molecule, we can say. But in some cases, it is being observed that although molecule has no chiral center, but it may be optically active because due to what? Different structure. Although it looks like identical structure, it can be divided into two halves, but one benzene ring in one plane, other will be in another plane. That means if one is horizontal, other will be vertical. In this way, there will be disymmetric structure, not asymmetric, that is symmetric structure. Disymmetric or asymmetric, both are optically active. If symmetry is there, then it will be optically inactive. Here it is optically active because one plane, it is just, if it is horizontal, it will be vertical. That's why. But in this case, not possible. Odd case always optically inactive, and even case will be optically active. So this is regarding the optical isomers. What are the optical isomers? That is these are called stereochemistry. That is special types of arrangement. That is enantiomers and mesomers, diastereoisomers. Which molecule will be optically active? Which molecule will be optically inactive? What are the condition of optical activity? So this is, then another important thing, let us discuss that what is what are retention? Retention, here we can say that if, suppose example, this is the structure, suppose this is your X, this is your H, this is your Y, this is your Z. If take OH minus and the product is like this, you see the difference in structure. If you see, let it be a plus. Let it be a plus isomer. Let it be a plus isomer. If you see the arrangement, all are H, Y, Z in same side, H, Y, Z same side. In place of X, OH is attached. So it will be plus. After reaction to H minus, same type of configuration is obtained. That is called retention. Retention means same, that stereochemistry remaining same. The stereochemistry of the product is remains same as the reactor. That is retention. What is inverted product? Inverted product is called Walden inversion. It is also called Walden inversion. Means just opposite. For take same example, C, H, Y, Z and X react with, suppose, OR minus. Let it be OR minus. Let it be product is, you see, C, H. If you see, let it be plus. If you see the arrangement, this just opposite, mirror image. This one and that one just mirror image, and X is occupied by OR, but opposite. Just opposite, just umbrella. If you open the umbrella and just to when the umbrella position, when that high speed wind is blowing. When high speed wind is blowing, then umbrella will again inverted position. That is called S plus, which is minus. Just opposite. That is plus with minus. So this is called inverted product. Inverted means just plus convert to minus. Minus convert to plus. But if plus is same plus is produced, minus is producing same minus, that is called retention. Retention of the product. Here, racemic mixture. This is a very important part of the optical isomerism. That is type of product. In retention product, inverted product, racemic mixture. Racemic mixture means, is very important. If suppose you take C, H, and suppose it is Y, this is your Z and this is your X, react with suppose O R dash minus, let it be O R dash minus. When suppose it is plus, let it be plus isomer, and the product is like this. H is there, Y, Z and OR plus just opposite H, OR, Y and Z. Dekho. Here what happened? Here is plus, it will be plus, no change because configuration is same. But if it is plus, it will be minus. Same molecule is same. Product is same structure, same formula. There is no difference. H, Y, Z, O, R, H, your Y, Z, O, R. Everything is same. But configuration is different. Arrangement is different. That's why if it plus, it is minus. If plus minus of same molecule is present in a mixture, that is called plus minus form. It is called racemic mixture. It is called optically inactive. OIA, optically inactive. So racemic mixture is always optically inactive. Optically inactive. Optically inactive. Optically inactive means one plus isomer opposes another isomer. So it is external. One is coming, other is opposing. That's why it is called racemic mixture, and racemic mixture is produced optically inactive due to external compensation. It is called external compensation. External compensation. Due to external compensation means plus opposing minus. Both are different. Plus is there, minus is there. Of same isomer, same formula, but they are opposing in rotation. One clockwise, another anti-clockwise. Both are coming together means they will oppose one. They will oppose one another. That's why it will become optically inactive. Optically inactive. So retention means plus convert to plus. It remains optical activity remains. Inverted means it optical activity is remain. Plus convert to minus, only change. But racemic mixture is produced means plus convert to plus and minus. Minus convert to plus and minus. That means one plus opposing another minus. That's why optically inactive. So this is regarding the brief idea, brief concept regarding the optical isomerism. Okay, you practice more, you practice different examples from different competitive books. Okay, any doubt you have, you can consult me, to me. Okay, thank you all.